All right, so our next topic in air and aerodynamics is adaptations. So we're going to talk about animal adaptations. So animals, they need to adapt to be able to survive in their environment. So animal adaptations are the changes in animals that allow them to survive in their environment. So for example, dolphins and birds have adapted to give them the ability to propel themselves through water and air. So we'll watch a quick video here on how birds can teach us to build better airplanes.
It takes a lot of energy to fly, and so philosophically you might wonder, why bother? Watching an animal do something completely crazy, like a pirouette in air, like acrobatics or things like that, it really broadens your horizons in terms of like what is physically possible. That's the number one kind of lesson that I've gotten from doing research, is just the world is way more crazy than I ever had anticipated, and I don't think I'll ever be done being curious about it.
Researcher Vikram Balaga of the University of British Columbia studies the anatomy and movement of animals. He's especially fascinated with flight, how a bird flies, and how their bodies allow them to do things man-made flying machines can't.
There's reports of certain species that can basically stay aloft for like months at a time, and they just kind of like dip down occasionally to get food. They can kind of like sleep with half a brain on and relying on like winds and currents to kind of keep them going. There's a few hundred species of hummingbirds, and their wings can go crazy fast. 40 times a second to like 100 or 120 times a second. Flight is when an animal is flying, like a bird or a bat or an insect. They are very much responsible for generating the forces to keep themselves up, in the sky. They have to do it entirely with their wings. We're still trying to understand exactly all the different things that it takes to be a flyer and be able to power your own kind of flight.
To really understand how bird wings twist and flex, Vikram needs to manipulate them with his own hands. Living birds wouldn't work, so he turned to the dead ones kept in a museum.
In the first few weeks that I was here, I went over there and just played around with a few cadavers. Like there was a few like duck wings. I'd never really played with a duck wing before. It's like a very foreign object to me. Birds essentially have wrists and they have elbows, and it was principally those two joints that we focused on. Just because we wanted to see within the wing, what the wing is capable of doing, what the range of shapes the wing can take is, and how that might correspond to a certain style of flight or not. This is the wrist, and so the bird is kind of like sitting like that, with its hand coming down this way, forearm over here, and then the elbow is kind of tucked away in the back. Birds that soar a lot, like turkey vultures or eagles or albatrosses, they have a lot of limitations in terms of what their joints can do. There's a lot of like locking up of the wing in certain positions, and that helps them stabilize as they're gliding around in these like high force environments.
But this research can teach us more than just about how and why different birds fly. It offers insight for how humans might better create our own flight designs.
To what extent we can apply this knowledge to help design better, automobiles or aircraft or robots or things like that. Evolution has basically done these natural experiments, and it's interesting to think about how that might be able to help us. We wanted to design aircraft that had adaptable wings, that if a sudden gust of wind like hit an airplane and the airplane could suddenly just sort of like change its wing shape to accommodate. We can draw some inspiration from nature and see what nature has already tried and what has or hasn't worked. And so I ultimately hope that as I continue my career as a scientist, I can keep having those kinds of moments where I can look in places where other people may not have thought to look, or where it might feel stupid to look, but then you realize that there really is something there.
All right, so we're going to talk about birds and birds in flight. So like airplanes, the birds are also using the four forces of flight. But they are, of course, smaller than airplanes, and they also have different features or adaptations that allow them to fly. Most birds have, for example, hollow bones, like shown here in this diagram. So that's an adaptation. It reduces the force of gravity. It gives them an easier ability to lift into the air because they are lighter. Also, another thing is that their bones may be fused together. So this allows the birds to have fewer muscles and therefore results in less body weight. The feathers on a bird also contribute to their ability to fly. Feathers are able to catch air. Feathers also help form the shape of the bird's wings. And that's really important, is the formation of a bird's wing, and it's linked to its ability to fly. Birds' wings are hinged, which we saw in that video. This allows the birds to fold their wings or extend them as needed. Okay, so birds, that's how they get their thrust and lift. It is from beating their wings. Continuing with birds, so once in the air, some birds can glide without flapping their wings for long distances. So what they do is they can fully extend their wings, therefore allowing them to glide. Okay, so like we were saying, once in the air, some birds can glide without flapping their wings for long distances. And when birds can't glide, they fly by fully extending their wings on the down flap. And that's what allows birds to push air downwards, using the most amount of surface area that they have. Birds also have to reduce that surface area on the upswing so that their wings, so basically the wings will fold in towards their bodies. They can use their muscles to turn one wing slightly up and the other wing slightly down, and that will allow them to change direction in the air. Tails next. So tails are also part of the flying equation. They use their tails like rudders in boats to help them turn in the air and to help them stay balanced. Tails are also used to create drag. They'll point the feathers downwards to help the bird to slow down or to help them land. And that is similar to what we see in airplanes when we see the flaps on an airplane. This example here is on dolphins and barn swallows. So another thing we have to talk about is the streamlined bodies, streamlined shape. So both dolphins and barn swallows, they have streamlined bodies, and that shape, that streamlined shape, helps to reduce resistance when they're in motion. So it's that teardrop kind of shaped bodies. It reduces drag in the water when they're swimming, and it reduces drag in the air when the barn swallow is flying. So friction, drag, that happens when two things rub together. So a flat-faced organism will increase friction, drag, when moving through air or water. They wouldn't be able to cut through the fluid as much as streamlined shaped bodies. Here is an example we're looking at in maple trees. This is called helicopter motion. So maple trees, they drop their seeds in helicopter-shaped samaras, and the maple tree plant has adapted to dropping these helicopter seeds to ensure that these seeds will get spread near and far from the parent plant. So they fall in this helicopter motion. It has like these wings attached to the seed, and basically when the seed falls, it spins as the wings cut through the air. The wings, you'll see, also have a wider side and a narrow side, and that makes them spin due to Bernoulli's principle. So therefore, the seeds can fall farther away from the parent tree, and therefore it'll also reduce competition between the parent tree and the offspring plant. Okay, next we're looking at design features and drag, or adapting drag. So when we look at an airplane, like we said, it uses flaps. It'll increase the drag of air flow over its wings by using flaps. Flaps on both wings. Those flaps are usually down when the plane is flying or during takeoff. But then when it's time to slow down for landing, those flaps open up, which allows the air to rub against the flaps, and it'll slow the airplane down because of friction. So what a bird does, a bird will use its wings to increase drag. They don't have flaps on their wings, but they have the capability to open their wings up. So when birds are landing, they will increase the drag on their bodies by opening up their wings. That makes them less aerodynamic, less streamlined when flying through the air. Decreasing drag, airplanes are made aerodynamically. They will close their flaps to decrease drag. A bird, they will tuck their wings in when they're diving from high altitudes to lower altitudes, and that will decrease drag as birds cut through the air.